What's up YouTube? Welcome back to the channel, and in this video we will be continuing with our patterns, sequence and series. So in this video we'll be covering geometric patterns or geometric sequences and series, right? So at the end of this video, the objective would be for you to be able to identify geometric sequences and use the geometric formula to calculate the next term, or to calculate the unknown, rather to say. So let's get straight into it. So in the previous example, we were given something called an arithmetic pattern, where, let's say for example, we had a pattern that goes like 1, 3, 5, 7, 9, so on, right? And for us to be able to determine what follows, it's just for us to be able to find what we call a common difference, right? So we know that to get the next term, we just have to add 2. We just have to add 2 in all the patterns in this term to get the next one, right? So now, let's say hypothetically we had a pattern that goes like 1, 2, 4, 8, 16, and so on. So let's look if we can find a common difference. Okay, we know that the difference between 1 and 2 is 1. The difference between 1 and 2 and 4 is 2. And the difference between these two is 4. The difference between these two is 8, and so on and so on. And we can see here that we don't really have anything called a second difference, if you see, right? So this will obviously continue. The difference between these two is is that, and the difference between these two is that, and it will continue so on and so on. So it's very difficult. It's almost close to impossible to either find a common difference or the second common difference. So instead, what do we do? So in this type of pattern, we're not looking for what we call a common difference. We're looking for what we call a common ratio. So a common ratio is basically us saying, it's represented in a letter R, and it's basically us saying that for us to be able to identify, for us to be able to predict this type of pattern, we need what we call a common ratio, where we say the second term over the first term is equal to the third term over the second term, and so on and so on. And this will be T4 over T3, and so on and so on. So let's see if that applies. So we know that the second term is 2 and the first term is 1, right? And we know that the third term is 4 and the second term is 2. And we also know that the fourth term is 8 and the third term is 4. And we can see here that in all the outcomes we'll always get 2. 2 divided by 1 is 2, 4 divided by 2 is 2, and 8 divided by 4 is also 2. So now we've determined that in this situation we use what we call a common ratio. So to be able to apply this common ratio, we need to know this geometric formula that says Tn is equals to A times R to the power of n minus 1. And in this case, A still stands for the same thing. A still stands for the first term. It still stands for the first term. And as I've already mentioned, R represents what we call a common ratio. Common ratio. And obviously n would refer to the term, whether it's term number 1, term number 2, and then obviously minus 1 is just a number. So let's do a quick example to see how we can apply this formula to get the next term, or to be able to predict what the next coming term will be. So in this example, we're given the following pattern: 3, 9, 27, and so on. So the first question says determine the value of the next term, right? So here, obviously, you would probably do trial and error if you were not given or if you were not told that this is a geometric pattern. But in many cases, they do give you, right? So obviously you do your trial and error, try to find a common difference, try to see if it's an arithmetic or a quadratic, but we'll skip that part. Obviously you're going to do it on your paper or Yeah, you're gonna do it by yourself. We're gonna skip that part. Let's say assume that this is a geometric pattern. Assuming is wrong in math, by the way, so please don't assume in many cases. Use the information that you're given and try to determine using that information. So let's say, for example, they already told us that this is a geometric pattern. So we know that in order for us to be able to calculate the value of r, we need to say t2, let me just rewrite that, t2 over t1, and we know that this is t3 over t2, and last but not least, t4 over t3, right? So now that we know this, the term that we're looking for is t4, right? So if we wanted to find the value of t4 without using the geometric sequence, the geometric formula, what we would do is we'd say t3 over t2 should be equal to t4 over t3. We know that that statement makes sense. So now we're going to substitute the values that we have and see if we're able to calculate. We know that our t2 is 9 and our t3 is 27. So here we're just going to say t3 is 27, t2 is 9, and obviously we don't know what t4 is. T4 is our unknown, and here it's still 27, right? So now that we know that, we're gonna cross multiply, or actually no, we're not gonna cross multiply, we're just gonna divide these, and we know that we have 3 remaining over 1, and then we're gonna cross multiply from there. So we're gonna say 27 times 3, and obviously t4 times 1, so that will be t4 is equals to 27 times 3, which gives us that will be 21 plus 60, that will be 81. That will be 81. So that will be another way outside of other ways in which you'd use to calculate the value of the next term. So question number 2. Question number 2 says determine the geometric formula. So now that we've already determined, or we haven't, we've already we need to determine what our ratio is. We just say t2 over t1, or we can just use any one of the terms, and we know that t2 is 9 and t1 is 3, so we know that our r is 3. So now we say tn is equal to, and the formula says a times r to the power of n minus 1. And we know that the value of a in this situation, it was 3 multiplied by r is 3 to the power of n minus 1. So do we leave it like this? I would prefer you leave it like this. So yes, please leave it like this. There is obviously a way in which you can kind of simplify this, because obviously these are powers multiplied by the same base. In this case, you just say 3 to the power of n minus 1 plus 1, and that will give you 3 to the power of n, right? That will give you 3 to the power of n. So you could leave it like that, or you could simplify it to this point. It's your choice. So the next question says, hence, use the formula to calculate the 20th term. So they want us to find T20. So we're going to use the formula, obviously, to calculate T20. And we know that that's 3 to the power of 20. That will be 3 to the power of 20. And 3 to the power of 20 will give us value of, just going to pour. Okay. I'm not going to really write down the value because it's a very long number. But yeah, whatever number that you're going to put and get in your calculator, that's the number that you're going to get. And that will be your T20. So your T20 will be 3 to the power of 20. And that's how we'd use the formula, the geometric formula, to calculate the value of the next term. So let's do one more example and see if we can integrate that knowledge into our minds. So now we have this question that says, determine the first 3 terms of the geometric sequence, of which the 6th term is 128 and the 4th term is 32. So the information that we're given here is that this obviously is a geometric sequence, and we're told that the sixth term is 128, and obviously the fourth term is 32. So we need to determine the first three terms. So we need to determine the first three terms. So how do we go about determining the first three terms? So we know that the general formula, obviously, since it's a quadratic, it's a geometric pattern, the formula will be a to the power a times r to the power of n minus 1. And we know that we are given the value of t4, which is, I'm going to write it down, but then that would say, and then that would mean, we have the value of n as well, and we know that's 4 minus 1. So here where there's t4, I'm just going to replace by that value, and that value was 32. We know that the value is 32, and I'll have a to the power of a times r to the power of 3, which is 4 minus 1, which gives me 3, right? So this is the information that I have. This is what I have. I know that t4 is equals to that. So now I also know that t6 I'm given, it's equals to a times r to the power of, and in this case it would be 6 minus 1. So if I simplify this, I know that that was t6 was 128. 128 is equals to a times r to the power of 5, and that's the second information I have. So if you look at these two patterns, I have two unknowns. I have a and r being my unknown, right? So in many cases, when we have a situation where we have two unknowns that we need to find, we normally use what we call simultaneous equations to be able to determine the two unknowns, and that's what we're going to use here. So we're going to use simultaneous equations and try to find the value of a and r, and then take it from there. So here I will use this as my second equation, and I will use this as my first equation. So I'm just going to divide the two equations. So I'll say 128 is equal to a times r to the power of 5. And then I will say 32 is equal to a times r to the power of 3. And this is my first equation, this is my second. So I wanted to divide just to simplify things, but I'm just going to use the long process where I use substitution instead of elimination, right? So in this case, what I will do is I will manipulate the first equation and try to make either a or r the subject of the formula. Since in this case, I'll try to make a the subject of the formula since it's the easy one, since it's already a. So I'll say a times r to the power of 5 is equal to 128, and obviously I'll divide both sides by r to the power of 5, r to the power of 5, and these two will cancel. Now I have a equals to 128 over r to the power of 5. R to the power of 5. So now I will use this value and sub into my second equation. So let me just get more space. So in my second equation where there's a, I'm just going to replace it with the value of a, which is 128 over r to the power of 5. So now I'm just going to rewrite my second equation. It was 32, and then where there's a, I'm just going to replace by that value, which is 128 over r to the power of 5, and then obviously the other value was r to the power of 3. So from here I'll obviously cancel these out, and I have r squared remaining here. So now I have 32 is equal to 128 over r squared, and then I'm just going to multiply both sides by r squared, and obviously this will cancel. Now I have r squared, 32 r squared is equal to 128. And then from here, it's very simple. I just have to divide both sides by 32. 32. Now I have my final value as 4. I have my final, it's not even my final value. I still have to factorize this. And if I factorize this, obviously, I don't want to square root it. But if I do square root it, just don't forget to put plus, minus 4, obviously, plus, minus. So r will be plus, minus, and we know that the square root of 4 is 2. The square root of 4 is 2. So now that we've determined the value of r, we're not done. We're just going to take that value and substitute it back into the equation that we used, which was equation 1. So we're going to substitute the value of r and say 128 is equals to a times 2 to the power of 5. And to get the value of a, we know that that will be 128 is equals to a, and we know that 2 to the power of 5 is 32. So we're obviously going to divide both sides by 32 to get the value of a. And if we do that, we know that our final value of a will be a is equal to 4. A is equal to 4. Sorry, let me just make sure that I wrote that down correctly. Yes, a will be equal to 4. A will be equal to 4. So now we have the value of Tn. We have our unknowns. Now we can use the value of Tn. We're going to say 4 multiplied by, and we know that our r was 2 to the power of n all over to the power of n minus 1. So now remember, with our question, it says we need to use given the following, we need to use that to determine the value of the first 3 terms. So now that we have our Tn, to determine the value of the first 3 terms, it's very simple. We're just going to say T1 is equal to 4 multiplied by 2 to the power of 1 minus 1. Obviously, that will give us 4 multiplied by 2 to the power of 0, which gives us 1. So 4 times 1 will give us 4. And then T2, we do the same thing. So it will be 2 minus 1, and that will give us 4 multiplied by 2, which gives us 8. That's the value of your T2. And obviously we have our T3, which is 4 multiplied by 2, 3 minus 1, which gives us 4 multiplied by 2 to the power of 2, which is 4. So 4 times 4 gives us 16. It gives us 16. So just to reflect on the question and the steps that we did to find our answer. The question says determine the first 3 terms of the geometric sequence, of which the sixth term is 128 and the 4th term is 32. So the first thing that we did is we wrote down, since we were given that this is a geometric sequence, we wrote down the formula that we normally use to calculate the geometric patterns, and then we substituted the values that we have, and in this case we have T4, which was 32, and we also have N, which was obviously 4, meaning that it was the 4th term. And we did the same thing with the other value, which was 128, and obviously we have it was term number 6, and if we say 6 minus 1 here, we're going to get 5. So now we have 2 unknowns. The first unknown being 32 is equals to a multiplied by r to the power of 3, and then obviously with the second one we have 128 is equals to a to the power multiplied by 3 to the power of 5. Sorry, I didn't mean unknown, I mean like we have 2 equations, and in both equations obviously we have 2 unknowns, and we know that in equations where we have 2 unknowns, we always 99.9% of the times have to use simultaneous equations to find the unknowns. So that's what we did. We obviously used substitution, which was a bit long. Some of you would have obviously preferred to use elimination. You would have gotten to the same step, but we used substitution and we were able to find the value of r, which was 2, which was obviously 2, and we were able to find the value of a, which was 4, and from that we were able to find the value of the equation, or to deduce the value of the equation. And then now from that we calculated t1, which gave us 4, and t2, which was 8, and obviously t3 was 16. So another way you can kind of confirm if your answer is correct, it would be for you to say, is the ratio correct? And then you calculate if the ratio is correct, and if it is correct, then your answer is highly likely to be correct. So that is it for this video. If you haven't already, please subscribe, share, comment, like, and obviously tell your friends about it, and so on and so on. So that is it for this video. I will see you in the next video.